This video is about line integrals. First, let me give you some motivations. Why do we want to learn line integrals? Think about we have a very thin wire, and with a density function, say fxy. See, for every point xy, you have like a density. Okay. Now, if the density is a constant, the question is we want to find the mass of this wire. Okay. So which should be, if the density is a constant, say density is a constant times the length of the wire, then we find the mass. Okay. However, how about the density function is not a constant? How do we find the mass of the wire? Okay, the idea is same as, so now we can break this wire to many small segments. Okay. Now, for each one, you think this segment is very tiny, so you can treat the density function as a constant. Therefore, you can treat it as a constant. Say, pick arbitrary point. You say xi, yi. That gives you density at that point. Then times the length of that, which we call the delta S. This length is called the delta S. So, this things give you the mass of this segment, approximation for that. Now you have so many of them, you add them together. Okay. So that would give you approximation for the mass for this total wire. Okay. Now this is just approximation, and this approximation is going to get better and better if you let delta S goes to 0, right? Okay, that's something, we give this sense a name, we call C. Okay, this curve we call it C. Okay. C f x y ds. Okay. Okay. So that's what we call this integral line integral. It's because it is integrated along a line or curve. Okay, so we do need to find such things, which has been defined by this limit. Okay. There's another kind of line integral. Is find the work has been done by, what is the formulation for work? Force times displacement. If force is scalar, if everything, the work has been done just along the one line, then they will do it. Now, normally your force is not scalar, it's a vector. And the displacement is a vector too. Okay. So say my force here is a vector. Say 2D, okay? Could be three-dimensional, same thing. Say P, X, Y, and the Q. That's a vector field, remember? Okay. And then okay. Also, we're talking about, think about you move something from here to here. The work has been done along that curve. Okay. So D there is a displacement. This is a D. This is dx dy. Okay. So D there really can be, locally can be written dx dy. It's two component. Okay. So since the force is not at every point, your force could be different. Therefore, we do the same thing. We break this to many strips. Then you can think about your forces. You can treat it as a constant. Therefore, we have another kind of a line integral, which will find the work has been done. Okay. Same thing. F there is a two component. Your D here is also vector. It's really the dx dy. Okay. So therefore, this integral, the dot, you perform dot product would give you P dx plus Q dy. Okay. So we got two kind of a line integral. Okay. If q is 0, so basically we got integral like this: fxy ds or fxy dx or fxy dy. Okay. So we got several kind of integral. Okay. And I told you the definition. Now the question is, how do we calculate this line integrals? Only thing we know how to calculate is simple one like this: from a to b, ft dt. T is a scalar. Now you have x and y there. Okay. Now this line integral is along the curve. Okay. Curve C. Okay. So the first thing is, every point on the curve, they must satisfy some relationship. Otherwise, they will not be on the curve. There's so many points not on the curve. Okay. So how do we describe a curve? Remember, curve can be written like this: in two-dimensional space. In the 3D, you just have more component yt. Okay, zt, same thing. Okay, so we know this things describe a curve. So what do you need to do? For the first kind of integral, your x depends on t, you just replace it by that. Y is also a function of t. Then you need to replace the ds. Okay. What is the ds? ds is this distance. Is equal to square roots dx square plus dy square. This is the dx. This is the dy. Okay. And this one can be written as dx, right here, dx dt square plus dy dt square dt. Just looks like you divided dt and multiply by dt. Okay. So you replace this ds by this dx dt square plus dy dt square dt. Then you change this line integral to a single integral like this, only depends on t. Okay. Now, for here, 1t equal to, you got a curve. Okay, this is rt. 1t equal to a, you got this endpoint. 1t equal to b, you got this point. So this is from a to b. Okay. In other words, the first type of line integral, ds, can be changed to a single integral like this. dy dt square dt. So this formula is important. They tell you how to calculate first kind of integral. Okay. Important sense, you need write your curve in like r's of t. Okay. The second kind, f xy dx, same thing. From a to b, same curve. I mean the curve starting point when t equal to a, you got this point. T equal to b, you got that the end point. So same thing, you replace x by xt, y by yt. Now dx is equal to x prime t dt. Because dx dt equal to x prime t, you just multiply dt on both sides. Okay. Same sense, fxy dy. Okay, so those three formulas are important. They tell you how do we find the line integral. Okay. Basic ideas is you change your line integral, which is a new type of integral, to this kind, a, b, f, t, dt, only depend on one variable. Okay. To do that, you need to describe your curve. Write down this. Find out what your curve, xt, y sub t. Three-dimensional, same thing. Okay. Now, I will give you two examples, show you how to do that. Okay, first example. We want to integrate this line integral c x y to the fourth ds. My c here is a curve, which is the right half of the circle of x squared plus y squared equal to 16. So once you got a line integral, first of all, look at this. Is it ds or dx or dy? Okay, now let's see what our curve looks like, x and y. Now they said c there is right half of that with radius 4 here. So this is our c. Okay. Now, so to integrate this one, as we said, we need to find the equation for the curve, which means what is xt, yt. How do we describe this curve? Okay. So basically, for your homework problem, their curve either like circles or lines. Now this is a circle. Okay. For the circle, you're always able to write this one. It's like put a radius here. Is a 4 here, cosine t. Y is 4 sine t. Okay. As long as your curve C here is a part of a circle, this always works. Okay. So now we got integral like with the ds. So to find the ds, you need to find dx dt square plus dy dt square. Okay. So we need to find dx dt, yeah, which is 4 negative sine t, and the dy dt here is 4 cosine t. Okay. So and your ds here is square root 4 square is 16 sine square t plus 16 cosine square t, which give you square root of 16 give you 4. Okay. So we'll find that. Okay, we'll also need to find this integral c can be write something from a to b. Okay. So your curve say started here, ended there. Okay. So t equal to what? Give you this point. This point is 0, negative 4, right? So obviously when t equal to minus pi over 2 would give you, I call this point. Okay. I call this point A. Okay, you got a point A. And when t equal to pi over 2, they give you this point I call the B. Okay. Therefore, this line integral c, let's see what do I have here. X y to the fourth x y to the fourth ds can be written as a single integral from pi over 2, negative pi over 2 to pi over 2. Then replace x by 4 cosine t. Replace y by 4 sine t to the fourth. So you got a 4 to the fourth sine 4t. Okay, replace the ds by this, which we calculate that give us 4 dt. So now this become the integral. We do know how to integrate it. Let me simplify that. Give you, we got a 4 here, 4 to the 4th, another 4, so you got a 4 to the 6th, negative pi 2 over 2, pi over 2. Then you got a cosine t sine 4t dt. Okay, now let's integrate this. The variable substitution will do that. Let u equal to sine t, then du would give you cosine t dt. Then this will give you 4 to the 6th sine 4 to the t, give you u to the 4th. Okay. The things left is cosine t dt. Cosine dt dt simply give you du. Now you can change here negative pi over 2, or you keep that, change it back, replace u back to t. Now let me change that here. Okay, 1t, okay, u equal to sine t. 1t equal to negative pi over 2. Your u equal to minus 1, right? Okay, 1t equal to pi over 2. Your u equal to 1. Okay, we integrate this, give you 4 to the 6, 1 over 5, u to the 5, evaluate minus 1 to 1. They give you 4 to the 6. You do this one, you replace by 1, then subtract by negative 1, multiply 2. So you find your line integral. Okay. So important sense is, how do you describe your curve? Sometimes they give you directly. If they don't give you, you either got a curve or line. Okay, I will show you how to do both. Okay, now let's do example 2. Example 2, we want to integrate second kind of integral, line integral. Okay, this really is a two integral. Okay, this really means this. Okay, what's the C here? The curve C here is a line segments. From point 0, 0 to 2, 0, and from 2, 0 to 3, 2. Okay, now let's see what this curve looks like. X and Y. From 0, 0, this point, then to 2, 0. Here's a 2, 0. And this point, okay. Then from 2, 0 to 3, 2. So this point is 3, 2. Okay. So your curve C really is two parts. The first part is here and the second part is there. Okay. That's your curve C. Let me give a name. I call this C1. The first line segment I call C1. The second one I call C2. Okay, then your integral over C really is equal to integral over C1 plus line integral over C2. Okay. Now I'm going to do one by one. Okay, now let's look at the segment line 1, C1. Okay. C1 is a line from 0, 0 to 2, 0. So this is a curve, okay? This is a line. Line is a curve, okay? So how do you find this? We need to find the sense. Okay, this is a line. Remember, we learned how to find the equation of line, right? Equation of line in general is like this. Let's review that. X equal to x naught plus at. Y equal to y naught plus bt. Z equal to z naught plus ct. Okay. If you have 2D curve, then you don't have to worry about this. Okay, you just like the first two. Remember, what is x naught, y naught? Any point on the line, right? What is AB? AB, okay. Remember we have n here. N there for 2D, just A and B. What is n? A vector your line parallel with, right? For this case, you can find n by using this point subtract that point, which is like 2, 0, subtract 0 and 0, right? That's give you a vector your line parallel with, which is 2, 0. Okay. So this will be your A, this will be B. Okay. What is x naught, y naught? X naught, y naught is any point on the line, right? Okay. Now we can write it. X equal to, we use this point, origin, okay? 0 plus at, which is 2t. Y equal to 0 plus 0 times t. This is just 0, okay? Okay, then we change, then our dx equal to x prime. What is x prime? Dx dt, which will give you 2 dt. And your dy here, take derivative of this is 0. Dy dt is, why is it 0? Dy dt is 0 times dt, which will give you 0. Okay. Therefore, our line integral on C1, okay, on the first segment, is replace x. Okay, we have this xy dx plus x minus y dy can be write as a single integral. Okay, t equal to, look at it here, t equal to 0, they give you origin, right? So 0. When t equal to 1, you got a point right here. T equal to 1, you got a point 2 and 0. Okay, so t equal to 1 give you this point, t equal to 0 give you this point, t equal to 1 give you this point. Okay. So then replace x by 2t, replace y by 0, then dx. Since dy is 0, so that's it. 0 times anything, you got a 0. Okay. So the line integral on the first segment is 0. And now let's look at this is C1. Okay, now let's look at C2. C2 is a line from 2, 0 to 3, 2, right? Okay. Two, 0 to 3, 2. How do you find the equation of that? Same thing. You need to find n, which is give you AB. Okay. So use 3, 2. Let's use 3, 2. 3, 2 minus 2, 0 would give you this vector. Okay, this vector will be the vector your line parallel with. So we'll be like 1 and 2, right? Okay. Then we are going to use this point as we pick our x naught, y naught. You can pick either 2, 0 or 3, 2. Let's just pick 2, 0. Doesn't matter. So we can find the parametric equation for this line. X naught, which is 2, plus, this is your A, this is your B, okay? Plus 1 times t, and your y there is, y naught is 0, plus b times t, 2t. Okay. And your dx here, take a derivative of that. X prime, give you 1 times dt. Okay. Your dy here, take a derivative of that, give you 2 dt. Okay, now we're able to write this line integral along the segment C2. xy dx plus x minus y dy. Okay, again. Okay, t equal to what? Look at this equation. Okay, look at this equation. When t equal to 0, they give you the point 2, 0, right? When t equal to 1, they give you 3 and 2. Okay, so your t is between 0 and 1. Then replace x here. Replace x here by 2 plus t. Replace y here by 2t. Replace dx by dt. Then plus another one, 0 to 1. Replace x by 2 plus t. Replace y minus y, which is minus 2t. Minus 2t. Then replace dy by 2 dt. Okay. Now you know how to integrate here, right? This gives you 4t plus 2t squared dt, then plus 0 to 1, 2t minus 2t give you minus t dt. You can integrate that. You find your line integral of along the second line segment. So finally, you see there x y dx plus x minus y dy would equal to your c1 x y dx plus x minus y dy plus c2 x y dx plus x minus y dy. Then you just put those two results in. We're done.